Station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready.
Uniformed Services University of Health and Sciences. This is Mission Control Houston. Please call station for a voice check.
Station, this is Uniformed Services University of the Health Sciences. How do you hear me?
Uniformed Services University of the Health Sciences, I have you loud and clear. Welcome aboard the International Space Station.
Good afternoon, sir. This is Master Sergeant Danny Morissette, an enlisted to medical degree preparatory program student at the Uniformed Services University of the Health Sciences, the academic hub of Leadership Academy for the military healthcare system. We are all very excited and appreciate this opportunity. Here's our first question.
Hello, my name is Genesis Lipscomb, and I'm a student at the Washington School for Girls. And my question is, when and why did you decide to become a doctor and an astronaut?
That's a great question. I need to, first of all, start out by saying to everybody there in the audience, it's such an honor to be with you. I've got tears in my eyes. It's, you know, Uniformed Services University is the center of excellence for military medicine, and I am so proud to be a part of your team. And to answer your great question, I decided that I wanted to be a soldier first, and then I decided that I wanted to be a physician. And I perfected those trades at the Uniformed Services University there in Bethesda, Maryland. That's where I learned how to be a soldier to physician, a physician to soldiers, and to be a soldier physician. And I made those decisions while I was started to get an interest in high school, and then when I was a cadet at West Point, I decided that I wanted to become a physician, and there was no better place in my mind than to go to the Uniformed Services University to become a military physician. I did not plan my career around becoming an astronaut, and so that's why I always say I was a soldier, then a physician, and then an astronaut. I'm all three, but I decided in that order.
Hello, Colonel Morgan. My name is Second Lieutenant Jeremy Lawson. I am in the School of Medicine, class of 2020. And my question is, what is your role on the space station, and how does your background as a doctor contribute to that mission?
Right now, in this era of long-duration spaceflight, we train astronauts to do all tasks. So we all are jacks of all trades. We all learn how to spacewalk. We all learn to do robotics. We all learn the Russian language. We all learn about the systems on the space station. There is some specialization that comes with certain payloads here and there, and certain additional duties. One of those additional duties is crew medical officer. And so when there's a physician on board, obviously I'm a natural choice for that, but there's no requirement for there to be a physician on board at all times. And if I wasn't here, one of my colleagues with a background as a test pilot or an engineer would receive additional training, and several of my crewmates right now do have the additional training to be crew medical officers. So the short answer is I would be a natural fit for if there was a medical concern on board, but we are all trained the same, and we are all expected to be equally capable in all the tasks that are asked of us.
Hello, sir. My name is HM2 Danielle Kane. I'm in USU's Enlisted to Medical Degree Preparatory Program. What is the most important experiment being conducted on the space station related to healthcare?
Well, it'd be tough to identify just one. during the time that I'm up here on board the space station, we have over 300 different experiments ongoing, and they range from physical sciences to earth sciences, materials sciences. We do technology demonstrations. We do educational outreach like we're doing right now. But we also have a fair number of payloads, experiments that are biological science background, as well as human research. Some examples of two of those: one biology background. Biofabrication facility came on board since I've been here on board the ISS, and it's basically a 3D printer for tissues. A lot of relevance to military medicine because when we grow tissues in culture on Earth, it requires a scaffold. In microgravity, we're able to potentially grow structures that we wouldn't be able to do on Earth using a 3D printer. And so obviously that has some real potential for applications in military medicine. Also participated in something called microgravity crystals, growing novel protein crystals here in microgravity as well that show promise for use in developing cancer medications and medications in the fight against Alzheimer's and Parkinson's disease as well.
My name is Maya Sertsu, and this is my classmate Meg Latin. We're students at Washington Episcopal School.
Has anything unexpected happened to you or your team in space? If so, what was the solution and how did you prepare to handle the situation?
Great question, and what comes immediately to mind was some recent series of spacewalks that we did over the previous couple of weeks. My crewmate and I, Christina Cook, and I went outside a couple of weeks ago and installed some batteries, and these aren't batteries just like you think of AA's and AAA's. These batteries are about the size of, nearly the size of your refrigerator at home. And we uninstalled 6 old batteries and installed 3 new batteries, and one of those batteries didn't work. And this was a significant impact to our ability to power the space station. And within a couple of days, and really only a matter of about 3 days, the team on the ground, the mission control, came together with a plan to do another spacewalk to replace a different component to help us restore power, this entire power channel on board the International Space Station. And the crew that went outside was my 2 crewmates, Jessica Meir and Christina Cook, who I've known for years and are incredible crewmates. And they went outside. You probably saw some of the coverage last week, and they fixed that power channel. And it also happened to be the first time 2 women had gone on a spacewalk together, and they did a tremendous job, and they saved power to the International Space Station.
Hi, Colonel Morgan. I'm Maurice Yagle. I'm the Director of Manpower here at USU. My question is, how do you cope with the psychological stress of being on a lengthy space mission? Thank you.
Well, we have a tremendous support network. My medical support is led by Dr. Rick Schuring, who I believe is in the room with you today. He's my flight surgeon, and aside from my own family, my own wife, he is the person I talk to the most. I have an opportunity to talk to him set aside once a week for several minutes, and we exchange emails constantly. So he's in charge of my overall health from the time that I was assigned to the flight, all during my time on the ISS, and then in my post-flight period after I land. He's in charge of the team. I also have a psychologist and a psychiatrist assigned to me too that I also have conferences with every couple of weeks just to talk to them and let them know what's going on and how I'm doing. Then they also follow me through the entire cycle of my mission. And then we have a lot of great opportunities, support by our behavioral health professionals that also make sure that we have good entertainment on board, that we have access to our television shows, and we have music to listen to, and that we can stay contact with our families, and they help us take care of problems at home, and they help us set up public outreach events with people that we want to reach out to. So it's a tremendous network of people on the ground who help us deal with the effects of being away from our families for a long period of time and being in space for a long period of time. It's outstanding. I can't say enough great things about them.
Good afternoon, Colonel Morgan. Second Lieutenant David Carmack. I'm a first-year medical student here. My question is, if someone had a medical emergency on the space station, how would it be handled? And if necessary, how long would it take to transport them back to Earth?
Yes, we deal with medical emergencies. The way I like to view it is as a three-tiered approach. The first approach is prevention. We have a highly pre-screened population. We are imaged and tested inside and out, and so they really know what risk they're buying with each astronaut, and so that's our first method. Secondly, as I mentioned, like I'm in regular contact with my flight surgeon, Dr. Schering, on the ground. We have robust telemedicine capabilities, so we have the ability to consult over radio, over telephone, with face-to-face, Skype style, where we can actually see each other. We have medications pre-positioned on board. In fact, I brought a medical treatment pack just to demonstrate that, and some of the contents, familiar things like stethoscopes floating here. And then in extreme, we do have the capability of being able to evacuate a patient. The problem with that would be that if we had to send a patient back to Earth, then we would have to send all their crewmates too. So we'd have to send 3 people back. But theoretically, we could get somebody that had, say, a surgical emergency on the ground within a day.
Sir, my name is Second Lieutenant Brad Pierce. I'm a second-year medical student here at USU and West Point class of 2018. My question is NASA pioneering any techniques to perform surgical operations for medical emergencies during future long-duration deep space missions to the Moon and Mars?
The research that we do on board the ISS comes in 2 general categories. We do research for the benefit of humanity on Earth, and we do research for the benefit of further exploration. Some of the robotics technology that we've developed in support of the space station, like Canadarm2, and we also have a robotic arm just behind me on a platform here in adjacent to the Japanese experimental module as well. And so the technology we've developed in robotics has had direct spin-off to things like NeuroArm and some of the robotic surgical technologies out there that allow neurosurgical techniques to occur under MRI guidance. But the question I think you're asking is about exploration and what are we going to do when we go further away from Earth? And these are great questions. And the room that you're sitting in is filled with people who are going to tackle and help us tackle some of these problems of how do we deal with surgical emergencies far away. Is it something that we'll do robotically with remote guidance, or is it something that we'll actually have a crew member trained to the degree that they could comfortably perform a surgical operation? And I don't know that we know exactly how we're going to deal with that yet, but we need people in that room to help us solve those problems, because we are going back to the Moon for a more permanent presence and then beyond to Mars, and we are going to need to know how to solve those tough problems.
Hi, good afternoon, Drew. My name is Meg Sommerfeld, and I'm Drew Morgan's wife's cousin. Surprise! My question is on behalf of the DoD educational activity. Do you anticipate astronauts' medical training curriculum will evolve to account for long-duration space missions, and do you see a role for surgical training?
Meg, it's wonderful to hear from you, and what a surprise, what a wonderful surprise, and a great question. The answer is yes. I mentioned that there's crew medical officer training now, but that's actually amounts to only a couple of days of training to take somebody with a non-medical background and train them with the basic skills that they would need for the ISS setting, which, like I mentioned, is we are well-resourced and we have good telemedicine capability. But when we go back to the Moon and we go on to Mars, now we're talking about communication delays and not immediate communication, and certainly not the evacuation capability that we could have from the ISS. And so we are going to need to build more robust training capability into the crew that we fly. And whether that means that we necessarily have to have a physician on board is not a question that I'll be able to answer. I certainly like to think that that would be a good idea, but it's, again, one of those questions that we're going to be asking here in the very near future. These conversations ongoing right now, and it's a really exciting time to be at NASA and part of space exploration.
Hi, Colonel Morgan. My name is Jonathan Scott. I'm from USU's Consortium for Health and Military Performance. My question comes from Colonel retired Fran O'Connor, who couldn't be here today. His question was, now that you've been in space, how well does your training simulate your physical and physiological challenges you face? What has occurred that you did not anticipate?
Great question from a great officer and physician, Dr. O'Connor, a tremendous mentor of mine over the years. And yeah, that's a great question. So our physiologic training begins from the day we show up. One of the first things I did as an astronaut candidate was we took the zero-G ride on the Vomit Comet to experience microgravity. We do lots of training in high-performance aircraft. The T-38 is the vehicle for that. I also have been to Navy flight school to train. And the reason there is a lot of similarity between flying high-performance aircraft and the physiologic effects that you feel, but also the mental processes that your mind has to go through, the quick thinking, et cetera. In the immediate preparation before launch, we do some of the techniques that our Russian cosmonaut colleagues have been perfecting over decades. Tilt table and something similar to a Barony chair as desensitization to space adaptation syndrome. I participated in all those, and you know, I had minimal space adaptation or space motion sickness when I arrived. So anecdotally, I felt like the preparation was excellent. There was nothing during launch, during my time on board the ISS, or even during my first couple spacewalks that I felt like I hadn't experienced before. We're exposed to hyperbarics, to hypobarics, G-loads. It's the training's outstanding, and I think that we're right on the mark for preparing astronauts for spaceflight.
Colonel Morgan, my name's Second Lieutenant Steve Radloff. I'm a fourth-year medical student here at USUS. And my question for you is, what techniques have you learned for crisis management since becoming an astronaut, either during training or on board the space station?
Steve, I was told that you weren't going to be in the room. I'm so glad you're there. I hope Alex Viramosa was able to make it. And I just got to say that Danny, Alex, Steve, you guys are some of the finest examples of medical professionals that I have ever encountered. The greatest honor of my life was serving alongside of you guys and many medics just like you, and it warms my heart to see you guys so successful there. And Steve, I've forgotten what your question was.
Totally understandable, sir. I did too. What techniques have you learned for crisis management since becoming an astronaut, either during training or on board the space station?
Great question, Steve. You know, NASA, the ISS is a very, very complex system, and the ISS is only really a small fraction of what NASA does. And the thing that I've observed most about the way that NASA operates is it is able to master complexity by using teams and teams of teams, teams nested within teams with complex reporting structure. In the military, we're very used to a very hierarchical, very clear chain of command, but the complexity of the things that the problems that we're solving in space exploration at NASA on the ISS are complex, and it requires a more complex structure to solve them. And so I would say complex architecture to solve complex problems. Great question, Steve. Glad to hear from you.
Good afternoon, Colonel Morgan. My name is Ensign Ted Johnson, USU, class of 22, Naval Academy, class of 18. Go Navy, beat Army. Sir, what experiences in your special operations... Oh. I'll forgive that, sir. My question is, what experiences in your special operations background have impacted your success as an astronaut, specifically with respect to situations or challenges that require out-of-the-box thinking?
Well, a couple things come to mind. Certainly, I mean, that's my thunder right there in your question. The out-of-the-box thinking, I think, is one of the hallmarks of special operations. They're always on the thought leaders, on the cutting edge of how to solve problems in ambiguous circumstances with limited resources. But one of the things that really comes to mind whenever I talk about special operations and what makes it special is the emphasis on humans are more important than hardware, and the investment that we put on our people and developing them and training them is the most important thing that we can do, and it's something that NASA does well also, but it's something that was a core part of my experience in special operations. Certainly, much of the operational skill set that I experienced as part of my time in the units that I was in, definitely I've come to rely on a lot of those as I've developed as an astronaut. But the single one by far would be learning to be a good teammate, a good team member, a good team leader.
Colonel Morgan, I'm Bob Thompson, USU Chief of Staff. I want to thank you and NASA for sharing your experiences and expertise with all of us here at your alma mater and with those watching from military health system sites and DoD schools throughout the world. Thank you.
Thank you guys so much. It's been such an honor to be a part of this. And I just can't say enough. I'm so proud to be part of an alum of USUS, and so proud of you all of the decision that you've made to not only serve your patients, but to serve your country. Just so proud.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants from Uniformed Services, University of the Health Sciences. Station, we are now resuming operational audio communications.